Alright, 2.6, we're going to talk about special functions. So today we're going to be able to identify and graph step, constant, identity, absolute value, and piecewise functions. Step functions are new, absolute values are going to be somewhat new, and piecewise functions are new. But constant and identity functions are things that we've done before. In order to do the step functions, we need to take a look at this new symbol. If you want to zoom in, get a good look at it, it's this double bracket thing going on here. And this is something we've never seen before, so we have to know what it means. Well, this thing only kicks back integers, okay? So it kicks back numbers that are not fractions. And what you do is you do the integer number right below that number, or right that's just less than that number. So the greatest integer less than or equal to x. So for example, 7.3. Well, what's the greatest integer less than 7.3? Well, it's 7. And the greatest integer less than 4.9, it is 4. And you should try and guess what the greatest integer that is less than 1.5, negative 1.5 is. And hopefully you saw that it's negative 2, right? Because that's what's less than 1.5. You might have said 1 there. That's a temptation because you think 1 is less than 1.5. But we're negative numbers, so it would be negative 2. So how do we graph a function like this? Well, it's kind of confusing because our normal t-chart is going to look a little funky. So we'll have an x on this side and f of x on this side. And because if I was to put in like a 0, I'd get a 0. If I put in a 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, all the way up to 0.99999, I would still get a 0 because 0 is the least or the greatest integer less than all those numbers. So when I plug in x values, I'm actually going to talk about a whole range. So like let's start at negative 3. And all the numbers that are between negative 3 and 2, I plug in. And what does it kick back? Well, if I plug in anywhere from negative 3 to 2, it's still going to just kick back a negative 3. And from negative 2 to negative, oh sorry, that should be negative 2. Negative 1 is going to kick back a negative 2. And from negative 1 to 0, it's going to kick back a negative 1. And from 0 to 1, it's going to kick back a 0, right? And so on and so on and so on. So let me fill this in just a little bit more. 1 to, that should be an x there, sorry. 1 to 2 is going to kick back a 1. So let's think about that. We're going to graph all these parts on this line. But this whole thing is all on the line of y equals negative 3, or f of x equals negative 3. So we're going to have a whole bunch of little line segments in here. Let me show you what I mean. Let's just graph this part right here. So from negative 3 to negative 2 on the x, on our x coordinates, and all on negative 3 on our y coordinates. Okay, so negative 3 on our y coordinates is right here. And we said from negative 3 to negative 2. Well, let's think about that. That means I'm going to start at negative 3. And it said that I would be equal to negative 3, if you want to double check. See? Start at equal to, but not equal to the negative 2. That's because if I plug in a negative 2 to this function, now suddenly it's going to kick back negative 2. Alright, so I start at negative 3 for my x value, and I go to negative 2. But I don't include negative 2, I leave an open circle there. And that's all at the y value of negative 3. And now let's go to x equals negative 2 to x is negative 1. Well, it's going to look the same, another little line segment. And again, and again, and again, and again. And it's just going to keep doing this. So that's what a step graph looks like, or a step function looks like. So whenever you have this little thing, it creates a step function. Alright, let's talk about this next problem here. It says an auto repair shop charges $60 per hour of any fraction of an hour. Well, let's think about what that means. That means if I take my car in and they work on it for an hour, they're going to charge me $60. That means if I take my car in and they only work on it for half an hour, they're going to charge me $60. Take my car in, work on it for 1 minute, they're going to charge me $60. Kind of a ripoff, right? But sometimes there's businesses that operate like this. So, and also, let's think about something real quick. Am I going to have a negative amount of time that they spend, right? So this is going to be my time, this is going to be my cost. Am I going to have a negative amount of time that they spend on my car? No. Am I going to have a negative cost? No. So none of these quadrants are even going to be used. And we're just going to focus in on this one. And so let's make every 2 be our hours. So there's 1 hour and 2 hour and 3 hour and 4 hour. And let's remember that right at 1 hour, they're going to charge me $60, right? So $60. And everything less than 1 hour, they're going to charge me $60. Except for at 0, they're going to charge me exactly $0. 120 is going to, that happens from 1 to 2 hours. And then we go to 180 from anywhere from 2 to 3 hours, right? And I leave the open circle here because remember, if it's 1 hour, they're going to only charge me 60. But right as soon as it gets past 1 hour, they're going to jump it and charge me 120. Same thing with 2 hours. At 2 hours, they're going to charge me 120, but anything past 2 hours, it's going to jump right up to 180. So that's how the step function works. And we just graphed it. And there's a graph representing their, what they charge us. Kind of a ripoff if you think about it, but that's the way a lot of businesses work. A lot of phone plans work like that too. All right, let's take a look at example number 3 here. I'm going to just graph these. Actually, I'm going to say, why don't you graph these functions? The only thing that I want you to change is, instead of calling this f of x, I want you to call this g of x. That's because I shouldn't have a g of x and an f of x on the same graph that are actually different functions. So graph f of x equals 3, graph x equals -5, and g of x equals x. And just see what those look like. And if you're confused about what that means, remember that f of x is just like graphing y equals 3 or y equals x. It's the same thing. So go ahead and graph those. You may want to pause the video because I'll show you what those graphs look like in just a second. Okay, this is what your graph should look like. Let's talk about f of x equals 3 first. That's this red graph here. It's just really like y equals 3. This is called a constant function because it's just constantly the same thing, right? The whole time it's just going to kick back 3. Always, always, always. This graph, x equals -5, is not a function at all, right? Because it's just going straight up and down. So that's important to know. It's just not even a function. Not a function. And then this graph we call the identity function. And that's because whatever I kick in for x, it kicks out the same thing for y. So it has the same identity no matter what. So 5 kicks out of 5, 6 kicks out of 6, and so on and so on and so on. Alright, those are some ones that we've already graphed before. We already know how to graph those. So let's look at the next page. Alright, we're going to graph this function. F of x equals absolute value x. But let's make a t-chart. X and f of x. And I want you to plug in these numbers for me. And what I want you to do is just fill this number in right here for f of x. So plug it in, see what it kicks back. And then I want you to plot all those points. I'm going to have you guys go ahead and do that. And pause the video, and I'll put the answer up in just a second. Okay. There's the answers, what you should have gotten when you kicked those numbers in. You should have gotten these numbers back. If you plotted the points, it would have looked like that. And if you kept going, kept plotting or plugging in points for your t-chart, you get a V, right? You get this V-looking thing. And that's what an absolute value graph looks like. It looks like this V thing. And if you think about it, that's because when you plug in negative numbers, they turn positive. And when you plug in positive numbers, they stay positive. So this graph really can't go negative forever. We could kind of break this down into two functions. If we covered up the right side, we could say this kind of looks like f of x equals -x. And if we covered up the left side, we could say this kind of looks like f of x just equals x. So we could kind of break that up into two functions. And if we were to do that, we'd call it a piecewise function. Okay, it's a splitting of two functions. This is where, for all the values where x is less than 0, we'd use this top function, y equals negative x, or f of x equals negative x. And for all the values when x is greater than or equal to 0, we'd use this function on the bottom, which is just f of x equals x, which gives us this identity function right here. And that's a piecewise function. We'll get more to that later, but let's play with some more absolute value ones. I want you to make t-charts for both of these. So x f of x and x g of x. Let's plug in some numbers. Let's just use the same ones again. And find out what you get for f of x, what you get for g of x. Plot those points and see what it looks like. See what happens when you add 1 to it and when you subtract negative 2 to it. Go ahead and pause the video because I'll put the answers up in just a second. Okay, so we plugged in the values for f of x and I got 3, 2, 1, 2, 3. And that when I plotted those points, it gave me another little v, but that was just kind of up 1 unit. And when I plugged in the g of x into g of x, I got 0, negative 1, negative 2, negative 1, 0. And that moves that little v graph down 2 units. So it looks like these numbers on the outside here just move the v unit up or down. And that's it. So that's kind of nice. We can deal with that. So, you know, if I was to say absolute value of x plus 5, well, that's probably just going to shift the whole thing up 5 units. That's it. So let's go on the next page. Okay, now we have a piecewise function. Understand, what they're saying here is that f of x equals x minus 4 only when x is less than 2. And for everything else, we're just going to say that f of x equals 1 when x is greater than 2. So let's break this down so that you get it. This is kind of like we're saying, hey, let's graph the top one like this, y equals x minus 4, only if x is less than 2. And let's graph the other one, y equals 1, only if x is greater than or equal to 2. So, how would we graph y equals x minus 4? Well, I'd go down 4, and I go up 1 over 1, up 1, or back 1, down 1, and so on. Right? And I get this line. The only problem is, what happens when it equals 2? Well, it can't. When it equals 2, we're going to jump to this graph. And it's not equal to 2 on here. So when I get to 2, I'm going to actually leave an open circle, and I'm just going to stop. And then I'm going to skip to the bottom part, y equals 1. Well, y equals 1 just looks like this line at y equals 1. And when it's at 2, it says that it can be equal to 2, so I can draw a little dot and circle it in. And so this is how we draw a piecewise function. We break it up into 2 parts. There we go. Now if I was to identify the domain and range, let's talk about the domain real quick. Well, is there any x value that I can not plug in here? No, it looks like it's going to keep going to the right and keep going to the left, and there's no holes or anything like that, so we're just going to say all reals. What about the range? Well, the range starts from negative infinity and goes all the way to 2. I'm sorry, goes all the way to negative 2. And it's not included negative 2, so I'm going to use a parenthesis. And then it starts up again at y equals 1, and it just, yeah, it's just 1, right? It doesn't go up anymore, so I'll just put another bracket around it. And next, what I want you guys to do is just sketch a graph of all the different types of functions. Sketch a step function, constant, absolute value, and piecewise. Just do those little drawings right here real quick, and you can check with me in class to see if you did them right. Okay, adios.